All right, here we go.
Like I swallowed a bit of it accidentally, and it was just burning in my throat.
It was so hot. But it was really good. Yeah, it was tiny so good. But like, no, this is like, it was so good. It was so good at the same time. It's just like.
All right, we talked yesterday about, I gave you this yesterday of the four main ways to solve limits. First one was to factor, second one was to rationalize, third one was to use substitution, and fourth one was one-side limits. One-side limits we're not really going to talk about too much right at this point in time anyway. So substitution is the last one. Possible, yes. I'll let you know with some questions. So the question that you guys didn't hear up here was, is there a view from grades 9 to 12 on the exam? And I said yes, the test. I said yes, it's possible. Like, so like, how do I make you factor something here? I know, but I'll make you, I will probably make you factor something with the correct order, something like that. Okay, so here we go, example 1. And so this is going to be another light lesson. I'm sorry that I'm wasting your time here. Okay, we're just going to do 3 examples that I'm going to call today. If you guys want to work on your rest of your homework, the rest of class, that works for me, okay? So here we go. Example 1 says evaluate. Okay, this one can be solved by rationalizing, but I'm going to show you a different way to do it with substitution, because there are certain questions that can only be done by substitution. The whole idea of substitution in calculus is to take something that's messy and make it look less messy. I know that doesn't really make a lot of sense, but go with me. What is the messy part? Emma, what's the messy part of this question? Thank you, Emma. Thank you. Okay, but it's the square root of x, okay? So the square root of x is the messy part, okay? So what I'm going to do is I'm going to substitute, I'm going to set v equals square root of x. I'm using v because it's Valentine's Day today. Okay. Isn't that nice? That is nice. So then I'm going to say this turns my equation into limit.
Wait, what would it actually be if it wasn't Valentine's Day? Would it just be anything?
Any letter you can use. Okay. Okay, what is that? No, you're only Emma this time, no one else. What does that turn the numerator into now? V minus 1. Hey, Haley. Now for the tricky question, what does that turn the denominator into? Somebody help her here. Okay, if v is equal to the square root of x, what's x going to be then? What?
V squared.
V squared, right? Good. So everyone see that, right? Square root of x is going to be v, so then x would be v squared. They may say, Mr. Sadler, this isn't any easier. Oh, you are wrong. This is easier. No, how would I approach this one now with these?
You can do the squares and cancel.
Perfect. Do the squares and cancel. So I'm going to call this one, go to the next board. Equals limit. X approaches 1 minus 1 over v plus 1. V minus 1. Now, there's one thing I want you to be very, 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 very careful of. Okay? And that is the fact that we have a limit that x approaches 1, but in the expression there's only v's. So you have to go back and change it so that there's only x's. So I'm going to say but. V equals square root of x. So, really, what does that change my expression to then?
1 over square root of x plus 1.
Good. Okay, so everyone see what we did then? Okay. So like, we didn't really break any math laws, we just made it look easier to do them. And if your brain is working, you can say, well, yeah, this is difference of squares, root of x plus 1, root of x minus 1, and just cancel, and that's fine. Tanner, what's my final answer here going to be then? I'm going to substitute. Yeah, Tanner, yeah. Close, 1 over. Good. Okay, the root of x, because x is 1, right? So root of 1 is 1. 1 plus 1 is 2. Okay, you can see how potentially this might be helpful when you see square roots. Okay, this will be helpful to you very soon. And this is one who was out. Well, this is like the 1D we were talking about today, right? Where I factor root x. It's a similar idea to that. Okay. All right, let's try example 2. Are there any questions before I keep going? Sorry, make sense? Okay. Let's do one a little bit more intense here if I can. Oh, here we go. Now this question I will put on your test or something like it, and half the class will get it, and half the class will get 0. So I want you to do that half gets.
Could you solve this without using substitution?
Yes, you can. Not everyone can, some are short using substitution, right? So, and the substitution will have to come next question. So it's a good one there. But yes, if you can see how this can be done without, and do it without. All right, Cecilia, if you look at this question, what looks tricky with this one? The 3 over 2 doesn't look good. Okay. What does 3 over 2 mean again? What is x? This is going back to grade 11. What does that actually mean? Do you recall? 1.5 good? Root x is third. That's what it actually means. Okay. So with that, what should I substitute here? I think. Yeah, that's exactly what we're going to write on, okay? Now you guys are even ahead of me. I'm going to go slow it down. But you have to do it. Okay, I'm going to slow it down and just say, well, let c equals root of x.
C for candy.
C for Colin, it was, sorry. Because you want to zoom right ahead here. Okay. And once you see, if you don't see this question's difficult. Okay, but once you see that, you can say, yeah, well, C is root x, so that's C cubed. Okay. Okay, so Calvin is right on the money here. This is difference of cubes. I would like everyone to try this one with difference of cubes, or sorry, you have difference of cubes right now. Factor it out and cancel, and you can do it, okay? And call from yourself, so I'm going to pause the video. Mind to go through. So this is, as was mentioned at the back, this is a difference of cubes. And remember for these ones always, if there's one issue in the denominator and the numerator, those are always going to cancel for these. All right, Caleb. We're getting close to finishing this question up. So next step, please.
Now you just sub in 9 for C.
Close
Or
or no?
no, we want to C equals root x. Right?
Yeah.
So you have to turn that back
Well, you're not off the hook yet. What does that make this question turn into, please? Go ahead.
Wouldn't it be root x squared plus 3 times root x plus 9, but then wouldn't the square and square root cancel out?
Yeah. Okay, c squared is written there. Oh. C squared is written there. That's c is root x, c squared is x. We have sub in 9. 27. I think. Everything was sort of good. All right, we want to do example 3, then I'm going to stop. This one here is the biggest and baddest of all. Here we go, example 3. Okay, so instead of talking about English class, let's refocus here, because this is a question you're going to get on your test or your assignment. People are going to freeze. Okay, do not freeze with this one. You have to remember for substitution, every time you see a question and that looks, you're saying there's something that looks awful, that's what you substitute. Okay, that's your thing. So Brendan, if you're looking at this question, what's the messy part? On. So I'm going to right away, I'm just going to say I'm going to sub or set b equals x plus 8 to the 1/3. Now the problem is I don't really like that. Okay? The problem is because if I were to set that right away, I end up with b minus 2 over x. And what could I do with that? Well, the answer is nothing. So I'm going to try and use my algebra skills to isolate x here so I can have a b. So I can have a b in the numerator and b in the denominator, if that makes sense. Okay? All right. So, how do I isolate x? Anybody here? What's the first step to isolate x? Go ahead.
Cube root.
And not cube root. Yeah, cube root. Well, I cube both of them. So I cube. Right, so if I cube both of them, that'd be x, because you can't really inside the bracket deal with the cube root. Okay, but you can think if I cube this side, that gives rid of the 1/3, I cube that side, turns the cube. What's the next step I can do? Anything else? No, I don't want once.
B cubed minus x equals, or minus 8 equals x.
Good. Okay, now I need someone to be tremendously confident, because we're going to substitute place in this question. Can somebody be brave and give me what the numerator is going to be, the new numerator? Bailey, go ahead.
B minus 2.
That was the easy one. Awesome, Bailey. That was good. I shouldn't put you down. That was wonderful, Bailey. Good. What's the denominator going to be? Go ahead.
B cubed minus 8.
Yes. So you see what we did there?
Whoa.
Isn't that awesome? That is awesome. So at least pretend in your mind that's awesome, because it is awesome. It is amazing. Okay, so now you're going to factor. Cancel. B cubed minus 8. Somebody doesn't raise their hand today, but has some self-confidence. How do you factor b cubed minus 8? Bailey, go ahead.
Cubed.
Yeah, go ahead.
Which would be b minus 2 b squared plus cube b squared.
So that is the difference of cubes. Notice I'm doing this again and again and again and again today, just to remind you guys how important this is. Okay, if you're like James, you like synthetic division, that's fine. You can sit at the right answer, but this is quicker than failure side than off in any synthetic division. All right, so, yeah. Okay, why don't we have with Bailey's answer? Fine.
Because the B minus.
Yeah. Awesome. And you see what we're doing here, like, for all these limits we're looking to cancel, that's the main idea between most of these, all right? So I say the limit all right. And the tricky part. Can someone stub it back in? Go ahead.
For B squared, would it be x plus 8 to the exponent 2 thirds
Wait.
plus 2 bracket x plus 8 to the exponent 2 thirds plus 4?
Okay, this is the thing, it starts ugly, you turn it into something beautiful, and then it ends ugly again, okay? But it's all right. 7708 to the 2 thirds, I think is 4. 8 to the 1 third is 2. Now before you asked, you might have noticed pattern today. Is it 8 plus 8 plus 8 or 9 plus 9 plus 9, 4 plus 4 plus 4? They don't always work that way. Right, just the way I pick the questions today. Right. Okay, your homework tonight is numbers 5, 6, and 7 from that sheet that we did yesterday. I'm going to stop right now. Tomorrow, a full lesson. I'm starting to feel a little bit better. I got medication, so we will hopefully be able to do a real lesson for the full day. Okay? Some of this was clear a little bit, hopefully. Luke, good luck in your basketball tonight. Make sure to give somebody a good screen.